This podcast is on mathematically determining a rate law. You can determine them by inspection, but in the AP exam you need to demonstrate how you come to arrive at a particular rate law and the orders that are involved. And one of the ways to do it is mathematically. You can also do it with words and describing, but this is the math way. So that if you have to write this rate law, this is the data from the podcast that you saw where we said, oh look, the chlorine is held constant, the NO doubles, and the rate goes up. Oh, that's about 4 times, and then you can say, therefore, it is second order. Well, mathematically, if you were to plug these values in, you know that rate 2 over rate 1 would be equal to concentration 2 over concentration 1 to some power, and concentration of chlorine 2 over chlorine 1 to some power. In this particular case, the chlorine concentration is held constant. So if we put them in, we discover that 4 is equal to 2 to the power m. M turns out to be 2. So then we know it is second order in NO. Likewise, as you move on, we now take a look at sets numbers 1 and 3, for example. The NO is held constant, but the chlorine doubles and the rate doubles. So you would say that because they are the same, it is first order. But mathematically, looking at the chlorine only, you'll notice that we have 2.86 10 to the minus 6, 1.43 10 to the minus 6 equals. And in solving it, we just determine that 2 is equal to 2 to the n is equal to 1. And so we can come up with the rate law, k NO squared Cl2 to the first power, and then you go ahead and solve for the rate constant k the exact same way. And hopefully this is helpful in giving you a way to demonstrate what you're doing in the cases for the AP exam. It's also quite useful when the numbers aren't quite as, shall we say, neat as these, where it's clearly the rate doubled when the concentration doubled. In fact, if you have a factor that's other than a whole number, this would make it somewhat easier.